All right, so well, let's continue on with this piecewise function that we've been given. Now there are other kinds of piecewise functions, but this one's a pretty good example, so we'll stick with it. So this is an interesting question. We're told, well, what is f of k minus 2 if k is less than or equal to 0? And you look at that, and you look at this, and you go, what? Well, I'll tell you that in fact it's not that difficult a thing to remember if we remember that whenever we see this notation, it means that anytime we see x in our expression, we have to replace x with the quantity k minus 2. So what we really read this is, first, replace x with the quantity k minus 2. Right? So if I were to look at this entire piecewise function, anywhere I saw x, I'm going to replace it with the quantity k minus 2. So instead of x plus 2, it would be k minus 2 plus 2. Whenever k minus 2, try that again, not r, k minus 2 is less than or equal to negative 2. You'll notice what I just did right there was that anywhere I saw x right here, I replaced it with the quantity k minus 2. So I do that in the next piece. I've got the quantity x minus x squared plus 4. So this is going to be k minus 2 squared plus 4. And in this case, k minus 2 instead of x is between negative 2 less than or equal to, come on, Professor Peoples, pay attention. K minus 2 is greater than negative 2, but less than or equal to 5. And then finally, 2 times the quantity k minus 2 minus 1, whenever k minus 2, the quantity, is greater than 5. All right. Now, we are given this other condition right here. We're just told, well, what happens if k is less than or equal to 0? And then I go over here to this piece of the expression, and I notice that if I were to actually take my inequality symbol right here, if I were to actually take my inequality right here, k minus 2 greater than or less than or equal to negative 2, if I add 2 to both sides, k minus 2 is less than or equal to negative 2. I add 2 to the left, I add 2 to the right. I find that k is less than or equal to 0. So this is the only piece that I really need to worry about right here. What happens? Well, we're saying then that f of k minus 2 in this piece is equal to the absolute value of k minus 2 plus 2, so that when k is less than or equal to 0, f of k minus 2 is really the same thing as the absolute value of k when I simplify that down. And that's what I was looking for. That's it. All we're really doing is we're just looking to replace that. Now we could rewrite the entire rest of this function with k minus 2 and just simplify this all out if we wanted to. But at this point, we've actually answered the question of what f of k minus 2 looks like whenever k is less than or equal to 0. And so we're done.